Hey, so Belize, how are you doing today?
Hey, Japhlet. I'm doing good. How are you?
Very fine, thank you. It's really great to be on this live session with you today. It's super exciting. Like, I am delighted. Hello, everybody that's joining us from all around Africa. Thank you very much for joining us for another session of Let's Learn.net. Myself and Similizi are great enthusiasts of .NET technology. We love .NET. We work at Microsoft, and so yeah, it's one tool that we are really, really, really very passionate about. In this live stream, we're going to talk about containers in .NET, and we're going to try to break it down for you all to benefit. But first, let's go over an intro. I'll go first. I'm Japhlet Nwamu. I am a cloud advocate at Microsoft, and I get to focus on the .NET framework as well as helping people to build solutions with artificial intelligence using .NET. I also get to work with amazing tools such as Azure AI, Azure AI Studio, Copilot, and all the cool stuff that Microsoft has that are related to AI. And in this session, I'm not alone. I'm with a very good friend of mine who is also a cloud advocate. So, Melizzi, would you like to talk a little bit about yourself?
Yeah, thanks, Japhlet. Just like Japhlet has said, my name is Somele Zadigo, and I'm a cloud advocate at Microsoft, part of the data advocacy team where we work closely with the Microsoft Fabric. So I'm really passionate about .NET as well. That's why you see me here today and just learning .NET alongside Japhlet and everyone during this call. So I'm really excited to actually see what this session actually has in store for us.
Yeah, and it's always been great to be on these sessions with you, Melizzi. I always enjoy our interactions, both here at Microsoft and externally as friends. Interestingly, both of us are from Africa and based off Nigeria, Abuja in Nigeria. And Somelezi, I don't want to say that for you. You're based off.
Durban, South Africa. So, all of my Durbanites, welcome to the call.
Great. It's nice to be here with you all. Somelezi, would you like to take over?
Yeah, of course. So, today it's all about learning about .NET and learning together. But for this specific session, it's actually an interactive session. So make sure that if you want to follow along, you can be able to complete the interactive learning exercises. You can be able to watch videos and practice and apply your new skills that you're going to be learning together alongside Japhlet and myself by just visiting the link that you actually see on the screen, which is a learn module that actually covers what we're going to learn today. And again, like I mentioned, this is a live and interactive session. So make sure that in the chat you can be able to say hi to us. This is a live session. Say hi and be able to interact with us and ask questions. Japhlet?
Great. So, if you have not done that already, please head over to the comment section, say hi, ask your questions there if you have any questions. But most importantly, we'd love to learn where you all are joining this live session from. So please let us know. And it's not also a bad idea if you let us know what you expect to learn from this specific live stream. We'll be going over the comment section at intervals to see all of the amazing people who are joining us and also talking about these people, sharing some of the ideas, sharing some of the thoughts that you all have there with everyone on the series. So if you love us to acknowledge you, if you love us to call your name on this specific live stream, I think you should use the comment section. In this specific stream, we are going to, for this specific session, we're going to make it as basic as possible because we have the thoughts that or believe that majority of people who would be joining this would be new to containers, would be new to DevOps, and so we'll be explaining a lot of these things bit by bit. We would not be going so advanced. If you need to go advanced, yes, definitely, please be sure to check out the resources that we will be sharing with you so you can get more insights into that. But Somalizi, what are some of the things people should probably have idea about or probably understand so that you can benefit from this session?
That's a great question, Japhlet. So, some of the prerequisites that you would need to be able to benefit from this specific session is that you need to have some familiarity with command line based applications and familiarity with basic Docker concepts. So, don't worry, we are going to be learning all of these things together, but some knowledge will be very much beneficial for you to have like a much more interactive and a great experience whilst we're learning together and just going through the learn module itself. And again, I can't stress this enough. You can be able to complete this as we go along the session with us by visiting that link that we actually showcased earlier on. You're going to see it throughout the session. But before we continue, Japhlet, I'm pretty sure that we have some learning objectives out of this session. And what are the things that people can be able to expect right after completing what we're learning today?
Great. So, a lot of people might be new to concepts such as microservices. Some persons might also be new to technologies that actually makes working with microservices very, very important and fun, and how these different technologies collaborate with each other, how they get to work with each other, and how they relate. Most importantly, a lot of people might not know how to really build microservices, especially using the .NET language. And so in this session, we're going to be covering all of these things. Again, we'll be breaking them down to the basics as much as we can. And if at any point in time you do not understand anything, or probably you need some further explanations, you can definitely ask us questions. We'll go over this session by talking about an introduction into what this is all about, then talk a little bit about microservices, why they are important, and not just do the theory, because what's a session without some bits of demos and some beautiful things happening behind the scene? I mean, that's the part you're waiting for, Somalizi, right?
Yeah, most definitely. And I really can't wait to actually see that in action.
Yeah, me too. We're going to be having two demos. First, would show you two demos that are combined into one, actually. We're going to show you how you can upload, come up with a website, a web application, storing all of your details, all of the details that you would need, all the products that you would need for the store you'll be building. You would be saving it as microservices, and then utilizing Docker, you'll be able to publish that and, you know, preview it yourself, seeing the amazing stuff of how it's going to come to life. We're also going to talk about microservices orchestration. Don't worry, we'll explain what all of this means so you all can understand. I can't wait for us to get started. So please, Samilizi, would you like to help us with that?
Yeah, for sure. Obviously, we have to go through some housekeeping, which is an introduction around what we're going to be doing today. Because at the end of the day, it doesn't necessarily make sense for us to say we're going to be doing something that's more hands on with .NET and Docker. And then at the end of the day, we end up not actually having a full understanding or a basic understanding of what we're going to do. So, first up, we just look at the introduction as to what's going on with microservices, Docker, and what does this all mean, and how it actually gets embedded into .NET. So in recent years, enterprises are choosing to use microservices instead of monolithic architectures to meet user demand and increase scalability and availability in their large consumer applications. If it doesn't make sense, suppose that you started a new job as a software developer at, for an example, the Contoso Outdoor Equipment Company. Business is booming, and so is Contoso's websites that indicates whether items are in stock. That website is a monolith right now, but it's an ideal candidate for the microservices architecture. So a team member refactored the monolith website into a ASP.NET Blazor page application and a .NET Web API. Your job is to deploy the services. So what we're going to cover here today is to actually help you gain an understanding of what the microservices architectural pattern is and the problems that it solves. You can also be able to see how you can use Docker to implement the microservices architectural pattern with ASP.NET and a web API. So by the end of this, you'll have the foundation of how to build microservices with .NET and understand how you can use Docker to implement the microservices architectural pattern. So before we actually move on to what exactly is microservices, Japhlet, do you have an idea of what it means to have like a monolithic architecture?
Yeah, and anytime I think about it, it's very, very scary because in the past, we used to have all APIs, all sections of a specific solution in one place. So all the code base could be made up of thousands of lines. For example, think of a platform like Netflix. They must have started with a few movies, but as time went on, they started having thousands of movies, if not millions at this point, and their database became very huge. Now, think about it. If they actually wanted to go with the monolithic structure, they would have all the code in one place, and that could span over maybe 100,000 or more lines of code. Imagine me as a developer wanting to come over there and say, "Here, I need to effect a new change," and I have to go through all 100,000 lines to probably find the specific line of code where I need to make a change. That was, I can't even think of it because it seems very, very scary. Make one mistake and poof, everything goes haywire. But it had its good parts in terms of you could easily deploy, you could easily, run through the entire code and you don't have to do the deployment bit by bit. But it still had that limitation. Scalability, reliability was a major challenge. And so microservices is, making it a lot easier because instead of having that 100,000 line for the entire of code for the entire solution, why not split it into different sections? Why not split it into smaller parts, and then each team owns that part, can cater for it, less lines of code to go through, less issues to deal with. There's that flexibility when it comes to actually being able to make changes to the code, implement those changes without having to disrupt other parts. So I really think having to leave the monolithic architecture phase has been really interesting, and majority of the organizations we know today actually welcome microservices and they use them a whole lot more.
That is great. I couldn't have said it even better myself. But now you must be wondering as to what Japhlet is actually talking about when he says microservices. What are microservices and how you can be able to use microservices? And to give you a little bit of what exactly microservices are, I can be able to just give you a little bit of a background of what you can actually expect when you're using microservices and what they are, and you have that foundational level knowledge that you can be able to use when you're trying to implement such technology into your new software, into your new system, instead of using a monolithic architecture, as Japhlet has actually explained. So let's take a deep dive as to what are microservices. So the cloud really drives today's application development and IT systems management. Modern cloud applications need to be fast, agile, and massively scalable and reliable. Using containers can be able to help you deploy applications that meet all of those requirements. But putting an application into a container without following a strategic design pattern is like getting into a vehicle and hoping to find your way to a city without using a map or a GPS. So you might end up at your destination, but the route probably won't be the direct or the most efficient. So this is where microservices actually comes into play, where a microservices architecture is useful in this scenario. Microservices give you an approach to software development and deployment that's perfectly suited to the agility, scalability, and reliability requirements of modern cloud applications, in which, for an example, that example that Japhlet had actually used. But we spoke about microservices, and now we're mentioning microservices architecture and how is it actually useful in the scenario. What is it? What are the what's the basic information around microservice architecture? So let's look at that and see what the microservice architecture really offers. So for an example, in a microservices architecture, a large application is split up into a set of smaller services. Each service runs in its own process and communicates with other processes by using protocols like HTTP or HTTPS, which is something that we're all familiar with today, WebSocket, or Advanced Message Queuing Protocol, which is also called as AMQP if you want for short. So each microservice implements a specific end-to-end domain or business capability within a certain context boundary. Each microservice must be developed autonomously and must be independently deployable. Finally, each microservice should own its related domain, data model, and domain logic. You don't just go in there and build blindly. Microservices can be based on different data storage technologies like SQL or SQL if you like, or you can also use NoSQL or NoSQL if you'd like to pronounce it that way, and different programming languages that you're already familiar with. So, for an example, there's some key characteristics that you actually see on the screen of microservices. So for an example, they're small, independent, and loosely coupled. Each microservice has a separate code base that a small development team can be able to manage. They're deployed independently. A team can update an existing microservice without rebuilding and redeploying the entire application. They persist their data or the external state in their respective databases. So unlike in a monolithic architecture, microservices don't share databases. So you don't want what Japhlet actually explained earlier on, where you're using a monolithic architecture and then you need to be able to update that system. And then if something goes wrong, everything starts crumbling down. So in this case, microservices or a microservice architecture actually persists their data or their external state in their respective databases. So not everything is going to start crumbling down if something goes wrong. They communicate with each other by using well-defined APIs. Internal implementation details of each service are hidden from the other services. They also support polyglot programming. For an example, the microservices that make up a web application don't need to share the same technology stack, libraries, or frameworks. But for me to be able to explain this and it actually makes sense, I think Japhlet actually has something nice that actually goes into detail as to what really is a microservices architecture. So if I have Japhlet back up, he can actually show us a quick video as to what microservices architecture actually looks like.
Yes, sure. So just before I go over and show that video, I can see a couple of people in the chat section, and I just wanted to um, more of acknowledge them. So first, I can see we have Lori joining in, Lori Van saying hi. I can see Robert joining in from Kigali. I can also see Yusef. I can see Sundaram, and I can see Enzo. And I'll just go over some comments that have been shared by CR Enzo. The first, which says microservices mainly means that an app is splitted by domain and service database is each service is a quanta. I don't know the meaning of that, but each service has its own small database. Yes, exactly. So instead of everything being together, instead of everything using the same database, and when somebody needs to make changes, it affects the entire database. It can be splitted into different parts. And then he goes on to say, I think there's a question. The title is containers. Wouldn't be microservices with containers. Does that mean the title of the session? Well, if that's what you're talking about, then we will be touching about microservices in this session. But remember that containers are also related to Microsoft's microservices, because for these microservices to work, then you have to place them in different sections, different smaller bits, and these smaller bits are known as containers. So yes, thank you very much for pointing that out. Now back to the video. Um,
You know what I love about this recent comment? It actually shows the excitement to actually see what we have in store today for the specific session. I also can't contain myself. I'm not trying to have a pun intended thing, but I'm trying to contain my excitement as to seeing this in actual action. So yeah, this is great. It's great to actually see the interaction that we have from the audience around what microservices are, and also obviously, as much as the session is titled container, I'm pretty sure that something tells me that Japhlet has something in store for us a bit later to actually talk about containers, really. But you'll see that later on.
Great. So let me know if you can see my screen and hear the audio. I'm sure you should be able to. Um, Similizi, please confirm.
Well, I can't hear it from my end.
As a collection of smaller services. They are
Good.
highly maintainable and testable. When the services are small, the code base is much easier to maintain and test. They're loosely coupled. This is an important point. Services connect with each other on a service endpoint, so no two services know any implementation details about the other or have any direct references. Microservices are organized around business capabilities. What that means is instead of splitting a large application into more minor services based on size, you decouple them based on the business problem. Often, patterns like the domain driven design are used to identify the business problem and separate them in their own domain logic. They're owned by a small team. This is why people often talk about implementing microservices need a cultural change in the organization too. Every microservice is usually managed by independent teams that give the autonomy to decide when to release a feature or fix a bug without waiting on the entire team's release cadence. Microservices are independently deployable, having a service model based on business domain, autonomous teams managing them, and loosely coupled, they're packaged and deployed independently.
Yeah, just like I mentioned, that's actually a greater explanation than what I did. But yeah, definitely that's what a microservices architecture actually means and how you can be able to find your way around it. But it doesn't really stop there, right? So why the question is why develop by using a microservices architecture, right? We're trying to avoid that entire scenario that Japhlet actually gave us around using monolithic architecture. So microservices typically encapsulate simpler customer requirement functionality, which you can scale out or scale in. You can test, deploy, and manage them independently. An important benefit of a microservices approach is that teams are driven more by customer scenarios than by using specific technology. Each small development team develops a microservice based on a customer scenario. The team chooses the technologies it uses. Microservices provide long-term agility. Microservices also support maintainability in complex, large, and highly scalable systems by letting you create applications based on many independently deployable services that each have granular and autonomous life cycles. As another benefit, right, to microservices, you can be able to scale out independently. Instead of having a single monolithic application that you must scale out as a unit, you can instead scale out specific microservices. You can scale only the functional area that needs more processing power or network bandwidth to support demand instead of scaling out other areas of the application that don't need to be scaled. That means cost savings because you need less hardware in this specific case. Again, not everything comes crumbling down when something comes wrong. The microservices approach allows you agile changes and rapid iteration of each microservice because you can change specific small areas of complex, large, and scalable applications. Architecting fine-grained microservices based applications enables continuous integration and continuous delivery practices. You can see the great benefit around microservice architecture. It also accelerates delivery of new functions into the application. You can also run and test microservices in isolation and evolve them autonomously while maintaining clear contracts between these specific services. As long as you don't change the interfaces or contracts, you can change the internal implementation of any microservice or add new functionality without breaking other services. But back to the question that we actually had earlier on the comments, the session is titled Containers. So what role do containers actually play in microservices, or what role do containers play in microservice architecture? Right, so as you can see on the screen, we're about to get into that. And I know we were all excited to actually get into understanding how the containers are part of the bigger picture. So containerization is an approach to software development in which application or service, its dependencies and its configurations, abstracted as deployment or deployment manifest files, are packaged together as a container image. So you can test containerized application as a unit and deploy it as a container image instance on the hosting operating system. So if you didn't know what containers are, that's the basic explanation. So for an example, just as shipping containers allow goods of all kinds to be transported by ship, train, or truck, software containers act as a standard unit of software deployment that can be contained or that can contain different code and dependencies. Developers and IT professionals can use containerized software to develop or deploy code and dependencies across environments with little or no modification at all required. If it sounds like containerizing an application might be a great way to implement the microservices architecture pattern, it is. The benefits of using containers line up almost exactly with the benefits of using a microservice architecture. You have to note with these kinds of things that containerizing an application is not the only way to deploy microservices. You can deploy microservices as individual services in an Azure app service or virtual machines or any number of ways. Containers are the deployment tool that we'll use for our microservices for the rest of this specific session, in which Japhlet is probably going to show you how to do that. But before we actually get into that, there's another benefit that I actually want to cover around containers. So another benefit of containerization is scalability. You can scale out quickly by creating new containers to use for short-term tasks. From an application point of view, instantiating an image, which is creating a container, is similar to instantiating a process like a service or a web app. In short, containers offer the benefits of isolation, portability, agility, scalability, and control across the entire application lifecycle workflow. So the microservices you build in this specific session that you're going to see Japhlet actually walks us through will actually run in a Docker container. But you don't know what Docker is. So speaking of Docker, Japhlet, Would you mind taking us through what Docker is?
Yeah, sure, I would. Now, for containers, we have to use Docker, which is an open source platform. It enables us to actually be able to deploy our applications, our solutions, our services. They are portable, they are easy to be deployed, they can work by themselves because they are in containers. But most importantly, they can run either in the cloud, as we're going to see, or they can run locally on your computer. This company known as Docker really goes a long way in ensuring that technology is evolving and that will find new ways to actually work with technology. It utilizes cloud platforms like Linux, like the Windows vendors, like Microsoft, to actually bring this entire solution to life. So wherever you are, whatever you decide to use, whether again, like I mentioned earlier, you want to run it on premise or you want to run it in the cloud, you have access to be able to do so. Now, for you to be able to create your containers, Docker makes use of what we call image containers. And these image containers can actually run either on Linux or on Windows. But one quick question that might be on your mind would be, what is an image? Spoken about image containers, what's an image? Think, for example, about a developer who utilizes Docker and they need to create either an application or a service. Now they've created it, they need to bring it together, which they have done. They also need to bring along with it different dependencies. These different dependencies coming together can be utilized in a container image. For an image itself, it's just one static representation of the entire application or service alongside the configuration that makes the application or the service come to life and also the dependencies. So the image, when it runs, when it comes to life, basically, it becomes the container. And then the container is the in-memory instance of that specific image. But something interesting about a container image is that it cannot be, it is immutable. It lasts as long as you want to, it cannot be changed. When you build your image, the image itself cannot be changed. If you need to make changes to the application or the dependencies or the service, you have to create a new image. The reason why this is great is because it enables that the image that is used in the production is the same thing with the image that I used in development and in testing, and makes it lots easier for you. Also, in the process of using microservices and containers, we'll be utilizing something known as Docker files. A Docker file is a text file that contains instructions on how to build a Docker image. They are usually written with very minimal scripting language, and their goal is for you to utilize them to build and to configure your images. They are required for you to build an image, as we're going to see right from when you are starting to build your Docker image. For you to create a Docker image that contains your application, all you have to do is to begin by identifying a base image. And then once you have done that, you add all your files and your configuration to that base image. The process of doing all of this is actually what is contained in a solution that Docker has produced known as Docker Hub. For Docker Hub, you don't have to start everything from scratch. You have ready-made images that contains an application framework and contains all the utilities and tools of a Linux distribution, for example, if you decide to use one like Ubuntu or Alpine. Let's take, for example, that you want to create a .NET, an ASP.NET container, or you probably have one. You want to create an ASP.NET application. And that single application that you have created, you want it to be packaged into a container, you could head over to a specific site which we're going to be using. It's called the microsoft.com/.net/ASP.NET, which is going to be shared in the comment section. And that contains a lot of the resources, including the ASP.NET runtime that you will need. You can also customize an image by starting a container with a base image. And then once you have done that, it's very easy for you to make changes to it. You could do so by either copying files to the container from your local file and then running all the tools and utilities that you need to combine code. So in summary, a Docker file helps you to bring your Docker image to life. It includes a set of instructions that enables you create your Docker image using the exact same software that you will need to run your application and all the dependencies that are needed. Another interesting part about Docker files is that it runs on the latest .NET SDK, which is, well, for the Learn module, it still uses .NET 7, but once you can update at any point in time and even utilize .NET 8, gives you the ability to use a command known as .NET publish to actually publish your entire solution. As we are going to see from the code base and from the solution we're going to build, all you have to use is to create your container. And then once you have created it, you just publish it using the .NET publish feature. Notice that first you have the operating system, which is shown as .NET publish the operating system Linux. You could decide to use other operating systems within Linux. You specify them there, but would plainly use the Linux operating system. And another great thing is you could also specify the architecture. So you could either decide to use, like us, the x64 architecture. And then using the release configuration -c release, you can then push this out. This gives you the ability to actually control many aspects of the generated container utilizing all of these features. And you could even utilize what is known as MS build properties. So if you can use a command in Docker file to get some of this configuration, then you would also be able to do the same with MS build. But one quick question would be, why exactly do we want to build microservices within .NET? Why are we choosing .NET? Why do we decide to go with .NET? One key reason is because of the flexibility, especially when it comes to utilizing solutions on cloud, that .NET gives you the ability to. It's cloud first. Our solutions are cloud first. It's cloud native first. You can utilize at any point in time in the cloud. But something else I also love about utilizing microservices within .NET is that it is cross-platform. So you could decide to use on multiple platforms. You could decide to use on Linux, and your .NET code will still run. You could also utilize .NET images, like we mentioned earlier, that have been created on Docker, like the link I mentioned, which we'll be utilizing. And all you need to do, instead of having to build everything all the way from scratch up, you can just utilize them. So we've spoken a lot about microservices and done an intro into this. But as a means of summary, let's talk a little bit, or let's answer a few questions about these things we've spoken about. So Madise, this is an exciting part of Learn Live sessions when we get to work with everybody in the live stream to actually have a mini quiz, because they could be tired, just we talking and talking. So let's head over to the little quiz we have for this specific session.
Yeah, definitely. And this is what I actually love about Learn Life sessions is that we were able to actually get into knowledge checks and be able to check if everyone is following along with what we're talking about and also giving you a small breather from all the content that we actually gave you. So there's a few questions, like about three, that we want to ask you guys. And if you want to answer those questions, please do make sure that you answer them on the chat and we will answer them alongside with you guys. So don't worry about it. So let's have our first question up, Japhlet.
Great. So the question is, which of the following scenarios would be a candidate to become a microservice? A microservice. Is it a web API that returns a list of pizzas? B, a web API and a website that returns and displays a list of pizzas? C, a website that's deployed by using GitHub Actions, and D, a Docker image. And by the way, please include your answers in the chat section and we will go through them together. What do you think, Similis?
It's hard for me to tell because we've covered quite much to get to this point, but I think my best bet would be B. What could be your answer to this question, Japhlet? And everyone, make sure that you put your answers. Just put A or B or C or D on the comment section as we go along with this session.
Yeah. So I try not to tell people the answers. Again, we'll be giving you the wrong answers. So please don't go with what we say. You can just include A, B, C, or D. You don't have to type the entire answer. Just include the options and we would see. Something we mentioned about microservice is it's actually, if you remember, it's actually a bit of an issue of a specific application, right? A specific solution. And we have a complex, think of it as a very complex solution, a very complex problem, and you're solving a specific part, a very small specific part of a problem. That's a clue. I don't know if that's enough clue, but I think that's a clue for people to actually run through the options and see which the correct answer is. I don't know if you're correct, Simulezi, but let's check through the comment section to see what people are thinking.
Yeah, I might be doubting my answer right now, but let's see. We, we do have an answer there on the comment section, and there's another one, but I'm waiting to see more before I actually say I'm changing my mind. Maybe I should, maybe I shouldn't. But we did have a clue. We did have a clue.
Yeah, I can see German as saying it's option A. You might be correct. And I can see Ellie also saying A. Probably you are correct. Let's hope so. Um, let's see. What are your thoughts? What do you think the answer is?
Let's reveal the actual answer.
Yeah, I think we should. So it's A. Congratulations to everybody who confirmed that the answer was A. Remember, just one bit of the solution. All the entire application is doing is different, but it's just picking one section. It's an API and it's just returning the list of pizzas that are probably it's a company that deals with pizzas, ice creams, food, groceries, and a lot of things, but it's just picking that specific section and have utilizing microservices to actually bring that specific section to life. Let's go over to the next question, Smilizi.
Yeah, for sure. So the second question is what is does a Docker in microservices architecture pattern. So Japhlet actually covered this just a few.
So sorry, so Melizia, I think there are some audio issues from your end. So probably I should give you some time to fix that and then go over this question and have you back for the next. Great. So this question is, what purpose does a Docker image have in a microservices architecture pattern? Is it's a text file with instructions on how to build the microservice? Is it B, a Docker image is a static representation of a microservice, its configuration and its dependencies? Or C, Docker images allow hosts to perform load balancing and routing? Let's see the comment section. I can see a lot of answers for B already. So we have Yosef, we have Enzo, and we have Ali for going for B already. Great. Let's see how many more answers we'll get. So I can see another answer. TNL is going for B. I can see um, lots of answers, lots of answers. Bolahan is going for B. I can see Siwat is going for B. German is taking the bold step and going for A. Well, that's very bold. So let's go over and talk a little bit about Docker images. And remember, while we're talking about that, we said when you're having an image, it's usually a combination of the different piece of your solution. So your microservice itself, you have all the configurations and all the dependencies that comes along with that microservice. So rightly, the answer is B. Kudos to everyone that said B. And for those who actually thought otherwise, it's great that you actually thought otherwise and you have learned something really new from this, which is exciting. Now, quickly, let's move over to our third question. Why would a developer write a Docker file? The options: A, to create the initialization routine for the Docker engine. B, to create a text file with instructions for how to build a Docker image. And C, to create the code to run the microservice. So let's see. What do you all think? Docker file. German goes with B. Enzo goes with B. Keep the answers coming. Let's see. What do you think? Does it create initialization routine? Does it create a text file with instructions telling you how to build a Docker image? Or does it create the code to run the microservice? Yosef says B. Fair enough. Great. So the answer to this is B. Thank you very much, everyone who actually dropped their answers. Great. Now it's time for the part we all have been waiting for. We've had lots and lots of theory, lots and lots of talking, maybe boring for you, maybe not. And so let's dive in proper into some demo. This is the exciting part for me. And I'm sure it's also the exciting part for the rest of you in this session. For this demo, we'll be utilizing the Learn module that has been created. So please check through the comment section way at the beginning or somewhere at the bottom. The link to the Learn module would or should have been pasted. So please, you can do me the honors of opening up your that Learn module and walking through. Or you could go over with me as I walk you through the different things that we're going to be doing in this exercise, in this demo. For this demo, I would not be going to explain the really in-depth things. I would just be keeping it at beginner basic level. So explaining some of the basic things that you need to know about instead of going in depth. What we're going to do is paint a scenario, first of all, to understand what solution or what problem we are having in mind. Remember the Contoso outdoor equipment company that Somalizi mentioned. First, they have a product and then they have a store, and in their store, they have lots of items in the store. We'd like to bring this together to be able to build a single unit, a single application, to bringing them together to actually work as one. For this specific demo, we'll need to utilize the development environment. In the Learn module, it actually utilizes code spaces for some sections, and then for other sections, it utilizes Visual Studio Code. You could use either of them, but we are going to be utilizing Visual Studio Code for this entire demo. And so if you don't have Visual Studio Code installed yet, it might be too late to get it installed, but you can come back to this video and then get started with it. We're going to be using .NET to create the product backend image. Then we're going to use Dockerfile to create the product backend image. And then we're going to create a Docker image. We're going to run our container and see how this service comes to life, bringing together the two major parts. But just I'm going to reshare my screen at this point so we can dive into this proper. So when you head over to the Learn module, you would find the link to a GitHub repository, this one down here. And that GitHub repository contains the code that we would be utilizing throughout this entire session. As you can see, it's the mslearn-.net-cloud native. For beginners, what you have to do if you need to utilize this is to come over here, and if you have GitHub Desktop on your computer, you can open this with GitHub Desktop. So what's going to happen when you do this with GitHub Desktop is that it's going to open this entire space, GitHub Desktop, and you have the opportunity to clone your repository. Cloning your repository is collecting the entire repository from where it is stored on GitHub and then pushing it to your local computer to be able to utilize it here. I've cloned this before, but I had to take it down so I can start right from the beginning to show you all how to really go over this. But I'm going to clone it again, and you can see what happens when I clone my entire repository again. Now, here you have three options. The first takes the entire code, opens it up in Visual Studio Code. The next option is actually for you to be able to see the entire code base, the entire repository locally hosted or locally in your computer in the Explorer section, or you could decide to open it online on GitHub. But we're going to be opening in Visual Studio Code, and we already have Visual Studio Code open. So it's going to take a few minutes, and then it's going to open that up. Great. So here we have this. What I'm just going to do is ensure that I increase this so you all can see what I'm working on. So just increase this one more. And you can see in this corner, the entire repository has been created. So I'll just cancel this. And you see the different folders that we can find here. First, we have the dev container, which is a let me open this up. Yes. So within the dev container, you have the different files, the different containers in the entire application. We have one known as .NET Docker, which we'll be utilizing. We also have .NET-Kubernetes, which if you want to use Kubernetes, if you're conversant with Kubernetes, you can actually utilize from there. And for each of these, it's usually a JSON file which enables your container, makes it run, and .NET actually utilizes it behind the scene. But the specific um, one which we'll be using is .NET Docker, which you can find here. Uh, so here you can find .NET Docker. And what I'm just going to do is click on it and to open up the entire yes. Here you can find all the different things that are within the .NET container section. And if you notice, you have two sections. Down at the bottom, you have the product and you also have the store. Those are like two separate sections, which we would be utilizing so much during the entire period of this demo. Some other things you would need if you also want to develop your solution is to install some basic extensions. So I'll just go over here, and what I'm just going to do is come over to extensions. I already have these extensions installed. You can see that I have the dev containers extension. It has already been installed. When you come over here, it actually gives you the opportunity to utilize your Docker containers within uh, this environment. And then it also gives you the opportunity to do everything you need to do utilizing Docker. Another great thing is that you have to install Docker itself, which enables you to build, to manage, and to deploy your containerized applications utilizing the Visual Studio Code development environment. You would also need to download the WSL, which is somewhere at the bottom here, the Windows subsystem for Linux, because containers actually work closely. Docker containers specifically um, works with Linux operating system. You will need the Windows subsystem for Linux to get all of the Linux-based tools, the runtimes and utilities that you would need to work with your entire solution. And then if you want to do more, you might also need to get Dive, although we did not touch it in this specific session, but you would need to get Dive to actually see the images, the different components of your solution. Great. So now that we've successfully been able to do this, let's head over and begin building our entire solution. So let's go back, and what I'm going to do is minimize all of this that were opened. And now we have the .NET Docker, which is the main tool or main application that we would be utilizing throughout this entire session. So now that we have this opened, we'll come over to the top bar, or you can utilize Control Shift P, whichever you decide to use, and then you can include, you would need to type in a command. This command would help you to build this container and then open it. Because it is already a container, it's basically going to rebuild it and then reopen it. So we're going to click dev containers, then rebuild and reopen in containers. And as you can see, we have the different containers that are in this repository, but we're specifically going with the .NET hyphen Docker container. And so we're going to click that open. We go on and continue. And just one last thing I wanted to show you is the Docker desktop. So Docker has two applications. First, it has Docker Hub, and Docker Hub is basically for people who want to run their solutions on cloud or they want to use Kubernetes. But if you have a desktop application and you want to run your images and everything on Docker, you utilize Docker Desktop. And I have my Docker Desktop installed. These are all the images, containers that are running. We can come here to see the most recent ones that are currently being run. At any point in time while building our solution, we can always come here. Most importantly, we can deactivate any that is left running just in case we're utilizing subscriptions or we are utilizing our storage space. I just wanted to mention that. You could also come over and take a look at all the images that are within your solution. So let's go back here. And what this is going to do is rebuilding, the process of rebuilding and reopening our entire container solution. It's still configuring, and when it's done, we'll have our entire solution. So just give it a couple of minutes to actually complete configuring, and then we can get on from there. Again, remember, during the course of this entire demo, if you have any questions, please be sure to include them in the comment section, and we'll be sure to take a look at all of them as we go through the course of this entire demo. I'll just go through the comment section while we're waiting for this to get configured. So currently in the comment section, there are no questions. Great. So at this point, we have successfully been able to get done with our configuration, and we are good to go. We'll be using Bash for the different things we would need to do, building our entire containers, which is great. But we don't need to have to learn a new programming language. We just need to work with the basics, and then we go around every other thing that needs to be done. So first thing we're going to do is direct this entire repository to the specific container we'll be working on, which is back to terminal, cd, directing it to the Docker. Sorry, that's .NET hyphen Docker container. and then it's configured so that what we want to do is utilizing .NET Publish. Remember we mentioned .NET Publish earlier. Utilizing .NET Publish, we want to be able to actually publish this entire image that has been created. So we'll do .NET Publish, and then / publish profile. We could decide to make it a default container, or we could decide to also leave it this way. Now, there are two key things to take note of while doing this. As I had shown you earlier, going through this route works. We could also decide to go through the route of identifying the operating system we want to use, and also defining the specific architecture that we want to use for this. So we could decide to go through the route of the operating system, Linux, and then the architecture, which is x64, and our commands. Sorry, one last line missed. And a few errors made here. So let's just go back, publish. Back. Great. SH. And then publish profile. So let's just split that out. Mixed up the great. And we'll have the operating system done now. Now let's go over and do the .NET publish, and then publish this specific image. And now at this point, we're going to see that the entire the entire container is going to be published. So key things you need to take note of are the different sections or the different files in the solution file. If you notice, it has data entities, it has the store, it has products, and notice that it is highlighting each of those for the entire, it's reading the files that are within this specific um, container. So what we're going to do next is to check the different images that are available within this. And when you come over here, you can see all of them. You can see, for example, we have the store. It's the latest one because it was created 3 hours ago while I was experimenting. And you can also see the size of each of the images that have been created. The entire repository which we cloned, the VS Code, MSLearn, .NET, Cloud Native, contains 3.31 gigabytes of images. So we can see all of those things them. Now, the next thing we would need to do, remember, we spoke about Docker files. And we said they contain very minimal scripting language that actually set of instructions that can actually be used and connected to our backend. So what we are going to do is head over to the product section, and here we are going to create a Docker file. So for this Docker file that we are going to create, we need to include lines of code that have actually been included in the learn module. For the sake of time, we'll just go directly to the learn module and copy out all of those code that have been imputed there. So here, I can just come over here and I would have access to actually copy all of those code and paste them in here. This is in a Docker file format, so it would be reading all of those, and I'm going to definitely include them. So I'll just paste them in, and then I'll explain what the different code does. So for this, first, we're utilizing the 8.0 SDK. Remember I mentioned earlier that at the other point we use .NET 7, but we currently have the .NET SDK 8.0, and that is what we're actually utilizing for this project. Next thing is setting the working directory to the data known as data entities. And then we are copying the specific file known as data entities.cs project, which is a C# project, and then pasting it locally in the data entities folder. We're using .NET Restore to basically bring everything in, and then copying everything in this specific folder into the repository. Notice or take notes that we're using .NET Publish to actually bring all of this to life and make them work. So we'll go over and we can paste the second line of code in directory to source. Next, we're copying this file that is under products. Remember, I showed you we have products and we have store. So we're picking out the product, the C# project as we created under the products folder, and then locally bringing it into the source folder that has been created. Then utilizing .NET Restore, copying the entire everything in the product section, and then locally posting all of them to the image. The last code which we're going to be copying is this. Oops. And what we're doing here is that we are utilizing, remember earlier I also mentioned you have existing images that have been created, right? Images that have been created by organizations, open source images that you could utilize. Microsoft open source images are found here, mcro.microsoft.com/.net/ASP.NET 8.0, and so we are utilizing this. I can't see the comment section, so please, Somalizi, if there are questions in the comment section, be sure to let me know and I will just go through them. So next thing we're doing is ensuring that we're exposing this entire solution to different ports that would enable us to run it locally, and we're utilizing the so let me just yes, we're utilizing the 80 and 443 ports. Let's get this properly. Some typos here. Great. So there should not be space in between. And then finally, we're setting the entry point to be, or the entry point of the image to be .NET, and then passing it over as a product.ll file. We're going to save this. And once we have saved it, what we're going to do is come over here and do Docker build -t products backend. Remember, enabling this on the backend. Product is the backend, the store is the front end of this solution. So product backend column, this is going to be the latest. That's just ensure I'm not making any typo errors. Great, latest. And then we're going to do -f product, connecting it now. Oops, sorry. Product. Oh, that was another typo. S. Yes, product S, which is the folder, and then Docker file, which is the file we're connecting to. Let's ensure there are no typo errors. And then we go on. Yes, and we missed something which I have noticed I mostly miss, the full stop at the end. So please, while copying out or while taking note of your code, ensure to include the full stop as the end. And let's see, we have some errors. Failed to okay, so let's fix our errors together. So fail to solve, fail to read Docker file. Let's see what the issue is. This has been saved. Let's go over this again. -f Docker build -t products backend. What are we missing? Okay, I see what we're missing. I just noticed that I spelled Docker file wrongly. So let me go over and change that. My Docker file at the top here was spelled FLIE instead of ILE. So please be cautious, don't be like me, and let's run this. And you can see the entire code is running. Now, notice that we at the top here mentioned -p, which is something I wanted to highlight here. And what that basically does is it's going to create pods for us. So when you come over here, you would find two pods that have been created, one for the front end and another for the back end. Right. So these pods are used to locally access these different sections, either the front end or the back end. So let's go back and we can see that this has successfully run. So what we are going to do now is run this container and we test the service. To avoid typo errors, what I'm just going to do is go over to the learn module and simply copy the code there, right? Now notice something that's going to happen when I run this code. I'll run it, we're going to see the errors, and then we're going to fix it together. Notice something like port is already allocated. So because I had multiple containers that have been run, that I have created and I've utilized this specific port, I can't utilize it anymore. Remember when we went to Docker, we could see all the existing containers that are still running. We can see the images, we can see the volumes, and we can see everything. And with all of these, they are still connected. Because of that, I can no longer use this port. So what I'm going to do in this code is I am going to change the port, but I am going to take note of it so that I don't make a mistake. The learn module utilizes 32001, but I would be utilizing something different because that port is already being used. So I'm going to change this to 32101, and I'm going to take note of this. Remember, this file is running for the back end of our solution. Don't forget that. And I'm going to run this. And what you can see here is you have all of these details, which we're not going to understand. But when I take note of my port number and go over to my browser, so I come over to my browser and I do localhost, and then I change, localhost, I change this to, ours was 32101. Just wanted to copy that, 101. Because it's an API and we're picking the product, what is going to happen is we're going to have an organized JSON code. So let me zoom this in. And you can see it's so organized. It's giving us the different products that are contained there, also giving us the images that are contained. So we have first the solar powered flashlight, we have the description about it, we have the price, and we have the image. These are the details contained there. Let's go back and let me show you where these details are. So when you come over here in your Docker container, you would be able under store product, you'll be able to find the data, and you would also be able to find the store itself, the different objects that are in the store, which comprises all of those. You would also be able to find details such as the code behind the eShop platform or repository that we are utilizing. So all of those different bits are what comes together to actually bring this entire solution. When you come over to the data entities, you can also take a look at all of the files that we have been mentioning while all through this entire code base, in the entire code base or in this specific section. So that's the first part. That's how the backend usually looks like. Now, Let's get to talk about something else, which is also very key before we dive into the second part of this demo. It's called microservices orchestration. I wanted to touch on this because it's important for the next couple of things that we are going to be doing. So, Melizzi, would you like to talk a little bit, please, about this part? I'm sure your microphone is working properly now. Okay, so I'm not sure Melizzi can hear us, but let's head over to that part and let's talk a little bit about back to our solution, the Contoso solution. Hi, Melizzi.
Hey, Japhlet, can you hear me?
Yes, sure, I can now.
Clearly.
Yes,
Just need to
clearly
check.
better.
Okay, awesome. Right, so we're gonna cover a little bit about the microservice orchestration. That was a really great demo, Japhlet, and I know there's another part of that demo that we're gonna look at. So we're just gonna quickly go through the microservices orchestration, and I know Japhlet is gonna cover it a little bit more in his next demo. So take Contoso for an example. Our example that we're actually using is that they love the results of using a microservices architecture so far. The overall web application calls individual microservices to provide and manipulate data. So, but as more services are needed in this case, the overall system becomes more complex to scale out and actually manage. So orchestrators in this case can be able to help out for them in their specific scenario, specific solution. But how does that really work? So we're going to understand a little bit more of what an orchestrator really is. So an orchestrator, for an example, is a tool that helps you manage, scale, and maintain a containerized application. Using orchestrators for production-ready application is essential if your application is based on microservices or is split across multiple containers. As noted earlier on, in a microservice-based approach, each microservice owns its own model and data. The microservice is autonomous from a development and deployment point of view. So that's very important to note. These kinds of systems are complex to scale out and manage. Therefore, to have a production-ready and scalable multi-container application, you absolutely need an orchestrator. A cluster is one type of an orchestrator. So for an example, what you see on the screen, which is the diagram, it actually illustrates using a cluster to orchestrate the deployment of an application that's composed of multiple microservices. You use one container for each service instance. Docker containers are units of deployment, and a container is an instance of a Docker image. A host handles many containers, for an example, and it looks like a logical approach. An orchestrator helps deploy the containers and manage the hosts. So an orchestrator is really important to Contoso's specific scenario and solution, and is something that you would need to consider whenever you're building out your solution and you are actually using microservices and you want to bring in an orchestrator. But then, what's the real reason behind using an orchestrator? Why would you use an orchestrator? So there are many benefits to using an orchestrator with a containerized microservices architecture. Again, running away from that monolithic architecture. The orchestrator helps you combine applications that are made of many microservices in one deployable unit. That unit is then moved to a host via deployment. After the unit is deployed, the orchestrator helps manage the host. It can also automatically start the containers, scale them out with multiple instances for each image, suspend them or shut them down when needed. The orchestrator can also control how containers access resources like the network and data storage. In the end, orchestrators can perform tasks such as load balancing and routing when multiple containers exist on multiple hosts in a complex distributed system. So they can also monitor the containers and hosts' health. So in this case, really, they're really orchestrating everything within your specific solution that uses microservices. Then the last thing to consider is Docker Compose, right? When you are using an orchestrator into your microservices solution. But what really is a Docker Compose? In this case, is a fully featured orchestrator, which might be more than what's needed for Contoso's simple website. So what the company needs is a tool that lets it build multiple Docker images as a single unit and then deploy the unit. Docker Compose is a perfect tool that meets Contoso's needs in this specific scenario and example. So with Docker Compose, Contoso can use a YAML file to configure an application's services. The Docker Compose tool then provides a way to build the individual services and a means to start them. But it's also important to note when you're working with this technology is that the Docker Compose tool is installed by default with Docker Desktop, so it's easier to run all containers and their dependencies locally. For production scenarios, for an example, I would really recommend that you use orchestrators that give final control over the automatic deployment, scaling, and management of containers. But that's a little bit about what containers can do and what orchestrators can be able to do and can be able to help you out with your solution that uses microservices. But before we actually carry on, I'm pretty sure that Japhlet has said quite a mouthful during the demo, and now learning about orchestration, we need to freshen up our minds a little bit and go to a knowledge check.
Yeah, sure. So let's see if we can still remember some of the things we have touched on, but most importantly, the things Suminizi has mentioned in this specific section. So let's head over to the quiz section. I'm sure you all are ready again. I'm sure none of you are sleeping yet. So for our fourth question in this entire session, it is, what is one use case for an orchestrator? What do you think, Sumilize? The options?
My best bet could be. I think I'm gonna hold my answer because I just spoke about this. What's your idea, Jeffrey? Just to double check with you.
So the options here, first off, using an orchestrator to scale out and manage complex distributed systems of microservices, to hold the Docker images in source control, to automate security penetration testing. Let's see. Hmm. I think I probably would go with C because of the word security. I'm not sure about that. I might be wrong. Don't go with me. I might be wrong. But I think C. So let's see.
Yeah, let's reveal the actual answer. So the correct answer is actually A. So in this case, like I mentioned earlier on, orchestrators are tools that are used to manage the host on which containers run. So you can see the answer there. It says to scale out and manage complex distributed systems of microservices. Again, orchestrators are tools that are used to manage the host on which the containers run on.
Thank you for teaching me something new. And sorry for giving the wrong answer. I hope nobody believed me. But yeah, here we are. The next question is, what language is a Docker Compose file written in? Similizi mentioned this and I took note of it. but I'm not going to say the answer.
I am going to keep that to myself as well.
Don't think because and we're talking about Windows resources, up. Well, sorry if you do that. YAML, it's JSON. Let's see what people have. Wait for a few seconds and let's see. And it's saying B. Let's see. Come on, what are your answers? So, Simlizi, what do you think the answer is?
My best bet is actually B, just like German has actually put it on the chat as well, on the comments. It's B. I mentioned this as I was going through what an orchestrator does and also how to use the Docker Compose file within it. So YAML is the language that Docker Compose files are written in.
Great. Kudos, German, that question. Now, the last and final to be focusing on, and we are going to be, now we've learned about creating a Docker Compose file, utilizing, and in the end, just to confirm, hear me clearly. Can you hear me clearly, Samadizi?
I can hear you now. If you try to speak again.
Okay. For this specific session, we're still continuing with, but in this case, we're going to bring it and let's now bring together the up. Needs to do three things. Well, not for everyone. To code space, code space, in with everything that we need to do to create a Docker Compose file, some automatically created, but we're going to go through it and then run the entire container. So and this we have run through properly formatted in JSON, that just in case anyone is joining at JSON file looks like. I can see how everything organized in the different sections in the container. Is since this is terminal and then kill this, kill mine, and because we're starting, we are going to have to redirect repository utilizing. So remember how we did, we had to cd folder .NET hyphen docker house. Now that we have done that, the next thing we need to do is check, which you can find here. Remember, we're doing this so this is our Docker Compose file. So we're using the right. It has automatically narrow. Then you can check that out. First, if you have a Docker, you would need to come over here and manually add that. In the learn module, you have two code, and the first contains differences between both of them, while the other, the first, does not contains Docker file. Because for the second scenario, we have which is this. But a problem, Docker file only for the backend. So here we're going to come over and compulsory. It's not compulsory that you have to do this. You can run it this way and it will still work. Do is after the image, build, and then start connecting it now to the Docker file. Here is it's trying to take us back to of the repository, and it's connecting us to products. So I'm just pilot. Let me correct this since, and I am going to save this. Remember, we have to let's go back here and see the ports we used. 101 for the back end. So we're going to come back here and 32101 to 100. Great. So we're going to save, properly saved, and then we're going to build this image. Still remember how we build our image or publish it. We don't have that code suggestion anymore. Let's go over this with me. .NET p publish profile. Include the default container command, which right, it's not compulsory that you do this, but we're just going to run this. And we're going to wait a bit for the run. thing we're going to do is compose this. I'll come over here and do compose. So just to ensure we have this properly written, and this is properly saved. Let's ensure there are no type. And we got those file. So let's go where our issue been done. This is oh yes, we issued the wrong files. I took note of that. So I'm just going to copy the files here. Sorry for that error. Compose file. Yes. And I'm going to save this. So yes, please, so you don't have to go through the heartbreak as much as I'm going through it now. And guess we should be, yes. So we can see our backend has been created. It's recreating times, and then our front end has been recreated too. Notice an error. The port is already allocated. Quickly change this port and let's see. So now we're trying to connect the front end into run properly. So what we're going to do is hit tab, and here we're going, let me get that back up, and do local did, let's just confirm our port number, and our port number was, from here was 32100. So localhost 32100. And we have our sites brought together. Remember, it has connected both the front end, and this is how it has been built, and we can see that it has connected them together. The products that were mentioned at the back end here, all of the details has now been brought in. How nice it is. So we have been able to build an entire solution, yes, utilizing Docker Compose to orchestrate this entire solution, bring it to have something that is, something worthwhile. instead of having to go through tons of lines of code, instead of having on specific things, we have been able to come up with this for us. So we just had to utilizing different APIs created, connecting both of. I'm sure you were able to follow through this entire session. I know stations around the terminologies, around the different things you need to take note of. All of this to life has actually put things together. Again, if you feel like this help you understand things lots more, please be sure to go over to the learn bottom of the screen, or that would also be imputed in the chat, and then let you could always reach out to myself or Sumilisi. Every one of you on this session. So at this time, let's quickly run through. So for the summary, we have been able to see how amazing and how it enables us to actually build solutions. Yes, the cloud has changed how developers, how organizations build and see solutions, how they for them to reach customers in new regions, in new areas, they have to utilize for them to be able to deliver features, respond to users' needs, features within their solution, they have to utilize the features that the cloud presents. And the most important part is utilization to actually reduce the cost of running lots of the things that they run. The microservice architecture, as I've seen, helps us to address these needs while building a single application that of small services. Each microservice, as we have seen, to end domain or business capability within a certain context boundary, autonomously and be independently deployed. Containers is a common approach to building each application or your services. The dependency should and allow to part they can form container images. Once you have your container image for you to containerize your applications. It's a text file that basically contains instructions telling and build a Docker image. We also learned about the dotnet as directly enables you to create containers through the dotnet publish command to support these commands such as the Docker file. Compose file, which is a YAML Docker containers for build. We have learned that to be cloud native first, enabling you to include such as Linux in your microservices and still run them. The extremely fast capabilities, plus the fact that they are in .NET images created for you to utilize. Who actually use code spaces sure to delete so that it's not utilizing used Docker and Visual Studio. Sure that you delete all you have utilized in Docker desktop and utilize these tools. Every one of you spending going through, you had a great time on this. Everybody who also joined, I wanted to say thank you very much for part of this. It's amazing.
Yeah, thanks so much, Japhlet, for that quick run through to the second part of the demo, and obviously giving us a brief summary around it. Thanks to everyone that actually came to the session and be able to start learning about .NET and how you can be able to use containers and using microservices for your solutions. There is just one last thing. We have a few resources before we actually go, so that you can be able to look at it at your own pace without following this session. And you want to revisit some of the resources, you can see some of the related content on the screen. That you can be able to visit some of those links. They can help you learn more about microservices with .NET. And a few of the things that you're going to find there on those links is actually something that we actually covered during the session. And one last thing before we actually go, I know I promised, is we do have a Cloud Skills Challenge for this Let's Learn .NET for Containers. So if you can be able to go through the Cloud Skills Challenge, I think the link is going to show up on screen just in a few seconds. But if you can be able to go through that Cloud Skills Challenge, it'll allow you to have all of those resources in one place, and you can be able to start learning about .NET, how you can be able to use microservices, and you can be able to learn about, obviously, orchestrators, as we spoke about orchestrators earlier on, Docker files and containers, and how you can be able to use them in your .NET solution. So if you see, once you see the link on the screen for the Cloud Skills Challenge, make sure to go through to the Cloud Skills Challenge so that you can be able to get a better experience with the resources in one place. So it's going to be on the chat as well. So just give it a few moments, and then you're going to see it on the chat and be able to complete the Cloud Skills Challenge so that you can be able to have a full-on gamified interactive experience going through those learned resources. And the demo that Japhlet was doing, you can do it on your own at the comfort of your home. Thank you so much to everyone that actually came through. And thank you so much to our producer who has been running things in the background. Jamie, thank you so much for giving us such a great session. And thank you, Japhlet, for all those amazing demos. I learned so much today. Everyone else, have a great evening or a great day wherever you are, and we'll see you on the next one.
Great.